Okay, I'm going to make a warning here. There's a lot of sort of horrible notation in here. Sorry about that in advance. We're looking at spherical blackbody radiators. This is obviously an IBSL question. And we're looking at X, which has a radius R, which emits half the total power of Y. And then we're also told the absolute temperature is double that of Y. Let's look at what the radius of Y is. Okay, as I sort of pre-warned you, my apologies in advance for the amount of notation I'm going to use here. When I made this, I probably was thinking very clearly. I'm sure there's a better way of doing so. Feel free to tell me what it is. The way I've done this is as follows. Firstly, I'm going to use our Stefan-Boltzmann law, which is that the power goes with t to the 4. And I'm acknowledging the fact that we've got our Stefan-Boltzmann constant, we've got our area of a sphere, 4 pi r squared, and we've got t to the 4. I probably could ignore the 4 pi here and the sigma here, but I haven't. My apologies. We're going to do this for both of the planets, both of the blackbody radiators, I should say. So we've got px, power x is sigma 4 pi. And then we've got r, we know that it has radius r, and we've got tx to the 4. And I've done the same for y, but in this case I've got ry squared ty to the 4, because I don't know anything about ry, and I'm not assuming anything on ty yet. We're also told something about the power. We're told that x has half the power of y, py over 2, so px is equal to py over 2. What I've done, probably sillily, is to rearrange that and said, okay, I'm going to take the ratio of powers, py over px equals 2. Okay, so just make sure you're familiar with that. What I've done is put 2 up and px down. I've got py over px equals 2. Why have I done that? Well, of course, because what I've done is put in my expressions. Now, like I said, I probably could have cancelled some things earlier, but we've got the power of y on the top here and the power of x on the bottom. And if you are struggling to follow this quickly, please do pause the video, just sort of absorb it a little bit. I've essentially copied and pasted my powers in. These are going to now cancel, my sigma and 4 pi. I'm left with this product here. ry squared ty to the 4, r squared tx to the 4. Nothing different there. It's just the relationship coming from the Boltzmann law. I'm then going to remember that the absolute temperature of x is double that of y. So I'm going to put that in here. 2tx is 2ty. So we're then in a position to cancel the ty's because it's got ty to the 4 on the top and bottom. But we've got a 2 to the power of 4. 2 to the power of 4 becomes 16. And so we're left with ry squared over 16r squared is equal to 2. Because remember, all that way long ago, we were saying that power y over power x is 2. That 2 is the same one here. Why have we done that? Well, because we can now bring that r squared up to the top. We've got ry squared is now 32r squared. It's just 16 times 2. We're going to take the square root of that, square root of 32, which leaves us with a 4 root 2r, which is one of the answers. Like I say, there's definitely a neater, simpler, tidier way of doing that. You can feel free to show me that this is the way that my brain works. Again, we've mentioned it many times, squares, square roots come into a lot of the questions. This is a bit of an ugly one, however, it's certainly relevant, and all we're doing is applying our laws of physics. Feel free to let me know if you've got any questions.